Hello, beautiful people, and welcome. In this video, we are going to practice and review for our test. Now, this is going to be limited in the examples. We're just going to cover the material, and then on a separate video, we're going to go through the examples. So we're going to review all of the concepts on the test. Now, some of the concepts we will do in a separate video. I don't want this video to be too long, but I'm going to try my best to get as much information in here as possible. All right, let's go ahead and get started. So the first thing you're going to see on your test is the parallel lines cut by a transversal. So if you are in my class, I did pass you out this cheat sheet here. So these are all of the postulates or theorems that you will need to know. So for example, we have, let me show you here, we have alternate interior angles, which means you have opposite side inside. So opposite side and on the inside of our bubble. So those two are congruent, which means equal in measure. So when you're going through these, make sure you state what you have, what that means, and what that means. So what I mean by that is, what do we have? We have alternate interior angles. What does that mean? That means they are on the opposite side on the inside. And what does that mean? That means they are congruent. And what does that mean? That means they are equal in measure. Next one we have is same side interior angles. What does that mean? Well, that means they're inside our parallel lines and they are on the same side. So that means that these two angles are supplementary. And what does that mean? That means angles that add up to 180. The next one we have is corresponding angles. Corresponding angles, that means that they have the same position. So if I was to cover this one up, take this, copy and paste it, they'd be in the same location. So if this one is on the upper left, this one is on the upper left. If this one here is on the bottom right, then this one is on the bottom right, and so forth. And what does that mean? That means these angles are congruent. So this one right here is congruent to this one here. This one here is congruent to this one here, and so forth. Same with the other two. Okay. Now, the next one is the alternate exterior angle. So alternate exterior means they're on the opposite sides of the transversal and on the outside of the parallel line. So opposite side, transversal. So what does that mean? That means they are congruent. And what does that mean? That means they are equal in measure. A linear pair, I'm going to shift this up. A linear pair are angles formed by intersecting lines. Now, what does that mean? Well, linear pair means that they are supplementary. That means if I have angle 1 and I'm going to add that to angle number 2, that means both of these are going to be equal to, when we add them together, to 180. So the measurement of angle 1 plus the measurement of angle 2, that equals to 180 degrees. Another type of angle formed by intersecting lines is a complementary angle. And that means if I have angle A here, and then I have angle B here, that means that the measurement of angle A plus the measurement of angle B, that's equal to 90. Now the way I like to remember the difference between a supplementary angle and a complementary angle is that when you have supper, when you have dinner, when you have supper, you want a lot of food. So it's going to be equal to the larger angle. When you get a compliment for complementary, when you get a compliment, that means that person who's compliment you is right. Feels nice when someone compliments you and they are right, so 90 degrees. One more angle formed by intersecting line is a vertical angle. A vertical angle are angles that are opposite each other. So that means if I have angle A here and angle B here, angle A, the measurement of angle A, is congruent to the measurement of angle B. That means they are the same measure. And then same thing here, if I have one here and one here, that means those opposite angles are also congruent. Moving on, in addition to our parallel lines cut by a transversal, we need to prove that lines are parallel, not only given that they are parallel, but prove that the lines are parallel. Usually you'll see like a line L and a line M, and they say, how do you know? Prove that line L is parallel to line M. So these are your three theorems that you're going to need. You're going to need the same side interior angles, so same side inside angles. You're going to need the alternate interior angles theorem, and you're also going to need the corresponding angles theorem. So a good way to know if you have something that is going to prove parallel lines is, are they touching both lines? If they are touching both lines, then yes, you can prove it. So let's do the same side interior angle. So same side inside. So let's say if you have this one and this one, and I'm going to highlight so we can color code. So that means that because this angle is touching line M and this angle is touching line L, we can use the converse of that theorem to prove that the two lines are parallel. Another one that we can use is, I'm trying to find another highlighter, is the alternate interior angles theorem. Alternate interior, this one here, means if I have this guy right here and this guy right here, again, the yellow is touching line M, the yellow is touching line L, therefore we can prove using the alternate interior angles converse theorem that those two lines are parallel. And we got one more, corresponding angles theorem. The corresponding angles theorem states that if we have same location and same location, this one here, that means we can prove that they are converse. So here's another one. I'll do this one here since I already highlighted it. Let's choose a different color. I'll put in X just to show you. So if we know that this angle and this angle are congruent, that means we can prove that those two lines are parallel using the converse theorem of the corresponding angles. Moving on to triangles, we have two triangles that you will be dealing with. We have, well, actually many triangles that you're going to be dealing with. But first, let's talk about the interior angle sum and the exterior angle sum. So the interior angle sum, the measurement of angle 1 plus the measurement of angle 2, or let's use letters B, plus the measurement of angle C, all of that is equal to 180 degrees. So A plus B plus C, all of these are equal to 180 degrees. Now the exterior angle theorem, that one's a little bit different. If you have an angle on the outside of the triangle, that angle sum is equal to the opposite two angles added together. So let's say we have the measurement of angle QRT, so this angle here, that is going to equal to the measurement of angle T plus the measurement of angle S. So these opposite, the ones that are further away from the outside angle, those are the two angles you're going to be adding together for your exterior angle. Moving on to polygons. This is a many-sided shape, so we're not talking about triangles only, we're actually talking about a many-sided shape. So in order to find out what the sum of the interior angles are, so for example, if you have 1, 2, 3, 4, 5, 6, 7, 8 sides and 8 angles, so let me erase that. And we have 8 sides, 1, 2, 3, 4, 5, 6, 7, 8. So 8 sides, 8 angles. You're going to type in or plug in the number of sides or angles, whichever one you prefer, just not both at the same time, into the formula and then solve. So for example, since we have 8 sides, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to say I have 8 minus 2 times 180, and that's going to be the sum of the interior angles. Now you can do this another way. So if you have something that's, I don't know, pretty small, and that's easy to see, what you can do is you can create triangles on the inside by selecting one angle and drawing to the outer inside edges, if that makes sense. So not the one that's next to them, but the one on the opposite. So you have 1 triangle, 2 triangles, 3 triangles, 4 triangles, 4 triangles. Each triangle has 180 degrees. So this right here would be whatever 4 times 180 is for your interior angle sum. So 4 times 180, that is 720 degrees for this one here. Or you could just use the formula. Moving on, or moving backwards to triangles, let's talk about the circumcenter and the incenter in triangles. So a circumcenter starts out with perpendicular bisectors. So I'm going to highlight perpendicular bisectors, this one, this one. So if you have perpendicular bisectors, that means a few things. That means that these pink lines right here, these are going to be congruent. It also means that you will have triangles created by these perpendicular, or I guess by these pink lines, and you'll have the sides. So I'm going to just kind of close this one up, just like that, and this one here. So you can kind of see a triangle, and what you'll notice is you have this bisector, right, this perpendicular bisector, and a bisector means cut in half. Because this is a perpendicular bisector, it cuts this segment, what is this, IH, in half. Therefore, you have these two segments congruent. And that happens 2 more times in here. Let's see if I can get these to not get stuck. Here's your second triangle where you see the 2 bases congruent. And here's your third triangle where you have those 2 segment bases congruent. So you have not only these pink lines that are congruent, but you also have these two, and these two congruent. And that is from a circumcenter. So given a perpendicular bisector, that's what you have. Now, what if they don't give you a perpendicular bisector? What if they give you an angle bisector? This right here is an angle bisector that is given. And from that angle bisector, we have a few things. We will have these perpendicular segments, this one, and this one, congruent. Now, they're not a perpendicular bisector because it doesn't cut a segment in half. These are just perpendicular lines. And because we have an angle bisector, we will know that, I'm going to highlight this in green, these 2 sides are congruent, these 2 segments are congruent. We will know that these 2 segments are congruent and these 2 segments are congruent. So basically, to every angle, to the left, to the right, you'll have a congruency. So here's an angle, there's your congruency. Here's an angle, there's your congruency. There's an angle, there's your congruency. And because you have that yellow angle bisector, each angle does get cut in half. So it cuts the angles in half because they are angle bisectors, and that is something that's given to you. All right, moving on. Speaking of angle bisectors, so what does that mean? So if we have a ray, AD, so this middle line, and this middle line bisects or cuts in half angle BAC. So what that means is if we have this line right here, this angle bisector, and it cuts the angle in half, then this AB right here, AB, is perpendicular to DB or BD, and we have AC perpendicular to DC. That means that these two are congruent. So what does that mean? So if you have an angle bisector and you have perpendicular segments, that means that this section right here and this section right here, these 2 segments, they are congruent. Now the converse of that is also true. The opposite of that is also true. So if you have these 2 segments that are congruent and you have that they are perpendicular, that means that we have an angle bisector, which means that these angles, or this angle right here, gets cut in half. And that would be the converse. A perpendicular bisector, which is not an angle bisector, a perpendicular bisector is where you have a line that cuts a bottom of a triangle in half. This one right here. And if it cuts in half, that means these two segments are congruent. So if you have a line that cuts the base of a triangle in half, that means that this section right here, I'm going to highlight it in green, and this section right here, these two segments are also congruent. The converse of that is also true. If you have that these two sections are congruent and you have a perpendicular line that is perpendicular to the base, that means that you have these two segments congruent. So that would be the converse theorem of the perpendicular bisectors. All right, let's move on. All right, isosceles triangle. So isosceles triangle is pretty cool. And that says if you have a triangle and you have angles that are congruent, this guy and this guy, that means that the opposite sides of those angles are also congruent. And now the converse of that says if you have sides that are congruent, the opposite angles are also congruent. And that's for an isosceles triangle. An equilateral triangle says, hey, if all of the angles are the same, then all of the sides are the same. And if all of the sides are the same, that means all of the angles are the same. For triangle inequalities, that is when you create a triangle or test if a triangle can exist. That means that we have the two sides, it doesn't matter which two sides, they have to be greater than the third side. So for example, if we take this side right here, I'll try to draw it in green, and if we have this side right here, when I add those two side measures together, they need to be greater than this third side. And you do that for all three options for your all three sides. If any of them are equal or if any of them are less than your third side, then it fails and you cannot form a triangle. All right, beautiful people. That is it. Enjoy the rest of your day. In our next video, we will continue discussing proofs and quadrilaterals. Bye.